Assalamualaikum warahmatullahi wabarakatuh. Inshallah, in this video, our group will explain about the formation and the synthesis of epinephrine. Before going through the IUPAC name, mechanism, and synthesis of epinephrine, here is the background of epinephrine. First of all, what is epinephrine? Epinephrine is a hormone and neurotransmitter used to treat allergic reaction, to restore cardiac rhythm, and to control mucosal congestion, glaucoma, and asthma. It's also known as adrenaline. So here shown the chemical structure of epinephrine, which also known as adrenaline. Now let's do the IUPAC naming for epinephrine. First, identify the parent chain, which is in this case, the parent chain is the benzene. Then number the benzene chain like 1, 2, 3, 4, 5, and 6. Now we can know the parent chain is 4-benzene, 1,2-diol. 4 indicate the position of benzene and 1,2-diol indicate the OH. Benzene 1,2-diol also can be replaced as phenol. After knowing the parent chain, there is a side chain which is ethyl. Do the numbering as usual. Next, identify the substituents attached to it. Here we can see that there are hydroxyl on carbon 1 of ethyl and methyl amino on carbon 2 of ethyl. So it is 1 hydroxyl, 2 methyl amino ethyl. It is not done yet since there is a stereogenic center which is the carbon 1 of ethyl. So we need to do the RS notational system. As you can see, that carbon bears 4 different substituents. So first, rank them in order of decreasing precedence that determined by atomic number. Therefore, here the highest is OH and followed by CH2NH, the carbon, and the last one is hydrogen. Next, redraw the 3 highest ranked substituents and you'll see the decreasing precedence of the 3 highest substituents appear in a clockwise sense. So the configuration at stereogenic center is R. Therefore, the IUPAC name for the epinephrine is 4,1R, 1-hydroxyl, 2-methyl amino, ethyl, benzene 1,2-diol.
My name is Aina and I'm going to talk about the source and application of epinephrine. Epinephrine is a natural hormone and neurotransmitter that occurs in the human body. It belongs to the class of organic compounds known as catechol group that bound to an amine group that contain nitrogen, with the presence of a methyl group on the nitrogen side chain. Epinephrine is derived from tyrosine and amino acid phenylalanine. Epinephrine is sometimes referred to as a catecholamine hormone as it contains the catechol moiety. This is a part of the molecule that contains the group C6H4OH2. Epinephrine plays a central role in the stress reaction, which is the physiological response to conditions that threaten the physical integrity of the body. It is the active symptomatic hormone secreted from the adrenal medulla in the most species. It stimulates both the alpha and beta adrenergic system. When released into the bloodstream, epinephrine acts to increase heart rate and blood pressure, dilate the pupils, elevate the blood sugar level, and redistribute blood flow away from the skin and in organs. As a medication, it is used to treat several conditions, including cardiac arrest, anaphylaxis, superficial bleeding, bronchospasm, low blood sugar, asthma, croup, and as a local anesthetic. It is given intravenously by injection into a muscle, by inhalation, or by injection just under the skin. Epinephrine appears as white to nearly clear microcrystalline powder or granules. It is odorless and it has 183.2 gram per mole for its molecular weight. The melting point is 211 to 212 degrees Celsius. The aqueous solutions are slightly alkaline. It is very slightly soluble in alcohol and readily soluble in aqueous solutions of mineral acids. An organic compound of a catechol that contains a 1,2-benzene-diol moiety, which is a benzene ring with 2 hydroxyl side groups next to each other, Differentiate the unique structure of catecholamines. Catechol can be either a free molecule or a substituent of a larger molecule where it presents a 1,2-dihydroxybenzene group. Catechols enable to establish strong interactions with different substrates and have promoted catechol as an important anchor for surface modifications. Catechol appears as a solid and white to brown feathery crystals. It has faint odor and its molecular weight is 110.11 gram per mole. It has 105 degrees Celsius for its melting point and 245.5 degrees Celsius for its boiling point. The density is 1.344 gram per centimeter cube.
Epinephrine is actually adrenaline, which is produced in the adrenal glands as a hormone or neurotransmitter. But as time went by, we can see that it is now capable of being produced and manufactured and synthesized in the lab. And this is done by reacting catechol, also known as 1,2-dihydroxybenzene, with chloroacetyl chloride, C2H12Cl2O. And the product of this two reaction is then reacted with methylamine, CH3NH2, and reduced to form epinephrine, which is C6H13NO3, which is what the synthesized adrenaline looks like.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syamira binti Sulaiman. I will explain the synthesis of epinephrine or adrenaline. The synthesis will start with OH substituent, which is ortho-para-directing, and the next OH substituent will be at ortho or para positions. The first step is phenol is being oxidized by hydrogen peroxide as an oxidizing agent to form 1,2-dihydroxybenzene in the presence of catalyst. The second step is involving the electrophilic aromatic substitution. 1,2-dihydroxybenzene react with 2-chloroacetyl chloride, which is meta-directing, to produce 2-chloro-1,3,4-dihydroxyphenyl ethanol in the presence of aluminum chloride. This is called Friedel-Crafts acylation of aromatic compounds in which acylium ions are generated and attack the ring. Then the third step is methylamine acts as a neutral nucleophile to replace the chlorides in 2-chloro-1,3,4-dihydroxyphenyl ethanol, and the product is 1,3,4-dihydroxyphenyl 2-methylamino ethanol. This reaction is called nucleophilic substitution, or to be specifically nucleophilic acyl substitution. The final step of the synthesis of epinephrine is the reductions of ketones to secondary alcohols. Lithium aluminum hydride reacts with the carbonyl group in 1,3,4-dihydroxyphenyl 2-methylamino ethanol and reduce to give a secondary alcohol in 1,3,4-dihydroxyphenyl 2-methylamino ethanol. That is the final product of this synthesis of epinephrine or adrenaline.
Next, I will elaborate more about the reaction's mechanism. First of all, we have oxidation of phenol. Phenol undergoes oxidation with hydrogen peroxide. The catalyst will substitute OH ion on the phenol structure and produce OH ion. The final result for the oxidation will become 1,2-dihydroxybenzene. Next is Friedel-Crafts acylation. 2-hydroxybenzene reacts with 2-chloroacetyl chloride with aluminum chloride as catalyst. Aluminum chloride acts as Lewis base that will coordinate the halogens, generating an electrophile. The third reaction is nucleophilic substitution. The carbon-halogen bond in 2-chloro-1,3,4-dihydroxyphenyl ethanol is polar and attacked by the nucleophile. The halide in 2-chloro-1,3,4-dihydroxyphenyl ethanol will be substituted with methylamine. The last reaction is reduction of ketone. The alkali metal cation lithium will activate the carbonyl group by coordinating the carbonyl group, which enhances the electrophilicity of the carbonyl. The H ion will give protonation that yields alcohol, which in this case ethanol. Next, we'll be talking about the rate of the reactions. For oxidation of phenol, substituent OH hydroxyl is causing the effect on rate activating very strong. For nucleophilic substitution, amine group NH2 that will substitute producing 1,3,4-dihydroxyphenyl methylamino ethanone is very strongly activating. For Friedel-Crafts substitution and also reduction of ketone, this reaction does not belong to benzene reaction. Therefore, the rate of the reactions does not count.
My name is Athirah, and my part is about the effect of substituent of the electrophilic aromatic compound, which in this case is epinephrine. Basically, rate and reduced reactivity are the main causes that affect the substituent. To get the final structure of epinephrine, we have to identify which functional group to be at first. As epinephrine has 3 substituents, then 3 cases have to be considered, either to start with hydroxy number 1, hydroxy number 2, or acid group. Hydroxy is autopara-directing, meanwhile acid is meta-directing. As for that, observing the 3 cases here, we have to begin with a functional group of hydroxy, then followed by acid group to get the final result. I will explain the details in the next slide. We will begin the reaction for phenol as the first structure. Basically, phenol is a benzene with hydroxy substituent. Looking at the table 12.2 from the organic chemistry textbook, hydroxy function group is in autopara-directing. So whatever compounds comes next will be in that direction. It will be either in any of the 3 cross mark there, but they have to match with the final structure. Hence, by undergo the oxidation of phenol reaction, we will get 1,2-hydroxybenzene as the product. The next reaction is Friedel-Crafts acylation of aromatic compound. In this reaction, 1,2-dihydroxybenzene will react with 2-chloroacetyl chloride to get 2-chloro-1 in bracket 3,4-hydroxyphenyl ethanol. Even though acid is in meta-directing, it does not affect the directing of the product's compound, since it refers to the compound of the previous reaction, which is hydroxy group. And finally, for these 2 reactions, nucleophilic acid substitution and reduction of ketones to secondary alcohol reaction, it does not belong to benzene reaction. Hence, the rate and reduced reactivity does not matter.